Hello and welcome back. Today we'll be doing a question from A-level discrete maths, and this is a question about using the simplex algorithm. So let's get started. Maximize p equals 5x minus 3y plus 4z, subject to x plus y plus z is less than or equal to 10, y is greater than or equal to 2x, x plus 3y minus z is greater than or equal to negative 6, and x, y, and z are all greater than 0. This problem can be solved using the simplex algorithm, which is very similar to the standard algebraic elimination that one would normally be using to solve simultaneous equations. Pause the video now to have a think, and once you're ready, restart to see if you're correct. So we'll firstly start by converting all of the constraints to equalities, such as here. On the top, we have p minus 5x plus 3y minus 4z is equal to 0. Then, on the line below, we have that the first inequality is converted to an equality by the addition of a slack variable, s. Now, we can also convert the second one. Notice that we need to get all the variables onto the less than side of a less than or equal sign, and then we can add in a slack variable. Therefore, we have 2x minus y plus t is equal to 0. Similarly, for the third, we also have negative x minus 3y plus z plus u is equal to 6. And of course, all 6 variables, the original variables and the slack variables, are all greater than or equal to 0. We can now put all of these inequalities onto one large table. Here we have the starting simplex tableau. Now we need to find the lowest number of variable in the top row, which is the objective row. This is negative 5, and therefore we select the x row. Now we need to look at which of the x's are positive in order to help choose our pivot. We'll notice that the 1 and 2 are positive, and therefore we need to choose the 1 and 2 to possibly be our pivot. Now, if we divide the right-hand side by the x for both cases, we see that we get 10 or 0. Since 0 is the lower, then we choose 2 as our pivot. Now we need to divide every number in the pivot row by the pivot itself, which is 2. This should give us a pivot row of 0, 1, negative 1/2, 0, 0, 1/2, 0, and 0. We now need to add or subtract a multiple of the pivot from all of the other original rows. This will ensure that we eliminate all other occurrences of the variable x. Doing this should give our new simplex table over here. We can now choose our next pivot. Here, looking along the top, we see that we have negative 4 as the smallest of the original variables, and therefore this z column will be our pivot column. Looking down, we see that we have 1 and 1, which correspond to 10 and 6 over on the right-hand side. 10 divided by 1 is 1, but 6 divided by 1 is only 6, and therefore this element down here will be our pivot element. Notice that we don't need to do any dividing in this case, because the pivot is already 1. We can now subtract or add multiples of the pivot row to the remaining rows. And this gives us this new simplex table over here. Now we have a negative number at the top, and therefore we do need to change the table again by applying the algorithm once more. Here, our pivot should be this 5 over here, because it's the only occurrence of y that is still positive. Dividing this 5 down to 1, and then adding or subtracting a suitable number from the remaining rows, we should get this final simplex table over here. Now that there is no more negative number at the top, we may finally interpret what the table tells us. Here we can read across and find that p is equal to 174 over 5, and this occurs when x is equal to 2 over 5, y is equal to 4 over 5, and z is equal to 44 over 5. Notice now that s, t, and u are non-basic variables, and therefore they are all equal to 0. And that's the answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.